Good evening, everyone. Welcome to techXplore 1.0 session on Agentic AI. We are thrilled to have you all joining us virtually tonight. I'm Ravisha Ranasinghe, and I will be your host for this session, Hansini Danshika. To begin with, let me briefly introduce techXplore. techXplore is a session series organized by the Association of Computing Students at the University of Sri Jayewardenepura, designed to bridge the gap between academic learning and industry. Before we dive into today's session, we have a quick announcement for all of you. We are thrilled to let you know that every participant will receive an e-certificate for being a part of this session. So, to get yours, all you need to do is to fill out a Google form that will be shared during the session. So, make sure to pay attention and complete the form when prompted. With that said, I warmly welcome you all to this insightful session on Agentic AI. Let's get ready to explore the future of AI together. Over to you, Hansen.
Now, it's time to welcome our esteemed speaker for today's session, Mr. Sandil Ranasinghe. He is a full stack developer with nearly 6 years of industry experience and a strong background in deep learning. Over the past years, he has been deeply involved in exploring agentic AI and its real world application. Mr. Sandil is a proud graduate of the Department of Computer Science and Engineering at the University of Madras. During his time there, he actively contributed to the tech community, participating in Google Summer of Code, IEEE Extreme, and various others. With his vast experience and passion for AI driven innovation, we are thrilled to have him here to share his insight. So, without further ado, let's welcome Mr. Sandil Ranasinghe.
Thank you, Hansani, for that wonderful introduction. So, hi everyone. Today I will be conducting a session on agentic AI for everyone. So, give me just a minute to get my screen shared. Yes, can I quickly clarify whether this is visible?
Yes, it is.
Okay, wonderful. So we'll keep today's session simple. We'll go over an introduction to agentic AI. So we'll see how agentic AI came to be, what exactly agentic AI is. We'll look a little at the structure and how you implement a simple agent. And then we'll look at agentic AI systems and architecting, and we'll wrap up once we have covered all of those. So first of all, I would like to talk about the rise of agentic AI. So before we go to agentic AI, we have to go through a few stages of evolution and how this whole AI system thing came about. So at the very beginning, we had rule-based systems. So a rule-based system is basically maybe you have some sort of logic with while loops, if else conditions, something like that. So rule-based system can only work with predefined data or conditions. So maybe sometimes you might have gone to some websites and you have seen those chatbots in websites, right? So some of those chatbots you can chat to same way you do with ChatGPT. But in others, you might have noticed you can't really type anything out. You can only select some options. Maybe it will let you select a category. Then it will let you select commonly asked questions there. And then if nothing solves your problem, they will say, okay, send us an email. So that is something called a predefined data or conditions. So rule-based systems work like that. LLMs, on the other hand, can essentially do some sort of pseudo reasoning, or they can talk about anything that is within their knowledge base. So basically, you can just ask a question and have an answer given to you by an LLM without predefining what you need to ask and answer. So when you're working with LLMs, you need to give explicit prompting and context. So maybe you open up Cloud or ChatGPT, you have to give it a prompt. And if it is something about, let's say you are asking about a particular book and maybe it has never been trained on that book, maybe you will need to give it some context also. So with the evolution of LLMs, you had such a thing that you could work with. The next step in the evolution of agentic AI is AI agents. So now AI agents are programs that use LLMs under the hood, but also do a few other things. So uh, with an LLM, with just an LLM, you need to explicitly prompt it step by step, tell it what to do, and maybe there are things it can't do. You will have to do them yourself and give it the inputs again. An AI agent, however, can complete a specific task independently using some predefined flows and tools. So we'll take a look at what those are later, but just keep that in mind. Finally, we have the end stage of the evolution, agentic AI systems. So agentic AI systems are autonomous systems with minimal human supervision. That means maybe you give it a very small input, say, okay, I want you to make this. That's it. You don't give any details, any context, any prompting. The agentic AI system can use whatever it has at its disposal. Maybe it's LLMs, maybe it's AI agents, maybe it's other tools. And it can, for the most part, make decisions on its own and do manage complex multi-step workflows. So that is what an agentic AI system looks like. So next, we'll first try to understand what AI agents are in further detail. So when it comes to agentic AI, an AI agent is the core building block of all agentic AI. So what exactly is an AI agent? It's a program that uses an LLM as well as any other tools it may have at its disposal and specializes in doing some sort of task. So it uses an LLM to reason and to make decisions. And then it uses the tools and the LLM at its disposal to do things like converse, tasks, and display a degree of autonomy. So instead of a person step by step prompting, what an AI agent can do is it can sort of reason with itself. So if I say I need to do this, then it will tell the LLM, okay, this needs to be done. Again, these are some of the components commonly found in an AI agent. So here you can see you have different modules such as memory, planning, tools, data, and LLM. So obviously there is an LLM that the agent core uses. Then the agent core coordinates actions between all of the other modules there are such as data retrieval, memory to keep track of conversations, data that results, etc. A planning module and tools. So we'll look in detail at what each of these does later on. But for now, let's see what sets an AI agent apart from just an LLM. So in addition to what an LLM can do, LLM means large language model. So that's something like GPT-3, GPT-4, Sonnet 7, whatever the large language models there are. So if you think about it, there are three main things that it can do. Perception. Perceptions means it can perceive its environment. That means it can get inputs from the users, it can get inputs from its data sources, it can get inputs from whatever tools it has at its disposal. So it can do that autonomously, at least to some degree.
Excuse me,
Then
sir.
decision. Yeah.
You are explaining English.
Oh, my bad. Sorry. Uh, it's visible now, right?
Yes.
Yeah. So again, these are sort of the core components of an agent. So we'll look at them in further detail later on. But now we'll see what separates an AI agent from an LLM. So like I was saying, an AI agent can perceive its environment. It can take data from multiple sources and it can see tasks that are running, plans that were made, etc. Then decision making or reasoning. So this is one of the most important things when it comes to an LLM. It can reason. So sorry, not an LLM, an AI agent. It can reason. It can say, okay, these are the steps I need to do. For each step, these are the tools I need to use. Uh, for each tool I need to use, these are the sorts of inputs that I need to use. So if you were only using an LLM, a human would have to make those decisions one by one. So I ask a prompt, LLM give reply, I make the decision about what to do next. Instead of that, an AI agent is capable of making its own decisions to reach what it considers an end goal. So maybe it can do one step and give a result, or maybe it can decide to do 10 steps and give a result. So that sort of decision making capability is there. Sorry. Next, actions and execution. So an AI agent is capable of doing actions or executing actions. For example, it can make calls to an underlying LLM and get responses. And then if it comes up with a plan of say 5 steps, it can execute each step by step. And if there are tools such as a code runner or an internet search tool or even a calculator, it can execute that and get a result from that. So it can actually do actions that a normal LLM can't do. Finally, in general, AI agents are capable of learning from the inputs they get as well as any feedback they get. This is more of an implementation specific detail, but generally AI agents can learn from feedback and data that they come across. So all of these contributes to the autonomy. So instead of a human being having to come there, make decisions, perform actions, run code, do calculations, and then give the results back to an LLM, an agent can autonomously do most of that. So again, here we have a comparison of LLMs versus AI agents. Give me a second. So as you see, LLMs have text generation, language understanding, and knowledge retrieval capabilities. So an AI agent, by virtue of having an LLM under the hood, has all of these capabilities. But in addition, it also can do these things. It can act and execute. So it can interact with real world through maybe if you have an API, some sort of REST API or something, a webhook, you can call that. You can call a function. Or maybe if there's a web interface and it has the necessary tools, it can maybe even open up a browser and go click something. And maybe if there are IoT devices which can take inputs from the agent, it can even do a physical action. Then reasoning and problem solving, it can make logical inferences, draw conclusions, and find solutions step by step. And all the while, it can review what it is doing and it can reason. So finally, autonomy and adaptability. So within set parameters, it can operate independently. So parameters depend on what you give the agent. So is it one agent? Is it a collection of agents? What kind of language models does it have access to? What kind of tools does it have access to? So if you have internet search, for example, you give it a vast amount of data access, and the parameters for it to operate are expanded to whatever tools at its disposal. So we'll look at a simple scenario. So this is very oversimplified, and some of these are probably unnecessary in a real world task, but we are going to do this for the sake of an example. So solving a math problem. So as you might know, large language models are terrible at calculations. One thing to note here, perhaps this new chat GPT interfaces, the applications they have, those might do calculations, but if you look at what they are doing, they are not actually directly doing it through an LLM. They also have an AI agent over there which can run code or call a calculating engine. So if you want, you can go to those applications and see how they work. But generally, LLMs are terrible at doing calculations and they can't call functions or use tools. So then what would I do is I would give the math problem to an LLM and ask it to explain how to solve step by step. Then, so this will give me like a high level explanation of the different steps I need to do. Then I ask the LLM for formula for any calculation. So if I have some sort of inputs, I ask it, okay, I need to give this to the calculator. What is the input I give? And it will give me some sort of formula to input. Then I copy those formulas and I open up a calculator. I put those values. And finally, I get all the values I have and I write a report. Maybe I use LaTeX or some sort of mathematical formula writing thing, and I make a PDF and I submit my PDF and do whatever. So that's how I would do it manually using an LLM and a calculator and a PDF formatting tool like LaTeX or whatever. But what if this entire flow can be done without manual intervention? So what if I just have to ask the LLM to give me a report for solving a math problem? So that's where AI agents come in. So now we'll look at in detail about the various components of LLM agents. So the most important component is the agent core. So it's a central controller that coordinates all the other components and makes the decisions and has a loop. So it continuously has a loop. Every single time some step finishes, it says, is there another step? Is this the end? Do I have to call some tools? Do I have to call one of the other modules? And then it executes each action that it sees as necessary. So it's what runs everything. It's sort of like a central processing unit in your computer or maybe your brain. So next you have memory modules. So memory modules are for retrieving and storing all the information that you want. So this includes short-term information that, for example, if you are in a particular step and your tool, to one of your tools, maybe you have a web search tool and it gives a list of things that you search for, then your plan had a plan about how to do that particular step, and maybe another tool give you some other data. So all of this is happening in a single step. So the memory module can short term store that. And in the long term, it can also save conversation history, knowledge, and other experiences, maybe user feedback, for example, and keep it somewhere. So there are various ways to organize this information, from simple storages to graphs to RAG systems. So memory modules are all about storing that information and retrieving them when the agent needs them. Fine. Third, the planner. So the planner converts high-level goals into structured, actionable steps. So if you give it a high-level goal, like, okay, I want to make a presentation. Then what the planner will do is, okay, it will break it down into steps. And for each step, again, it will break down further into steps until it can make a sort of an action plan. So let's say to make a presentation, first I need to let's say I give a topic and say make a presentation on this topic. Then I need to first break it down into a few subtopics. Then I need to retrieve some data about those. Then I need to, for each subtopic, I need to make a slide. And then finally I have to put everything together. So maybe it makes steps for each of those. And it decides, okay, for this you need to use the internet search tool, things like that. Finally, tools. So tools can be anything that you give a agent the ability to interact with and use. So this can be external system, this can be APIs, webhooks, internet search tools, calculators, and you can even give it access to another agent as a tool. So tools execute specific operations that the agent itself cannot do via an LLM call. So then those tools also can be used. So maybe if the planner says, okay, we need to do a calculation, then the core will look at that and say, okay, to do a calculation, I need the calculator tool. And then it will call that tool. So these are the core components of LLM agents. So maybe if you go into further detail and read around agents, you will see that there are other components, more complex implementations, but these are the core parts. So here you can see some examples of tools, and this agent here is the core, and memory you have short term and long term, and planning you have various sorts of things that you do in plan. So sub goal decomposition is breaking something into steps sort of. Reflection is looking at what you have done so far and seeing what you need to do. Self critics is sort of like seeing what are the problems here, and then if you are familiar with prompt engineering, you'll see how chain of thoughts are used in uh, generating good results using prompts. So that sort of a thing is found in the planning module. So the agent here in each step looks at what is needed, gets the plan, sees if he needs to retrieve anything from the memory, and whether he needs to call a tool, and then performs an action. So that action can be, it can be a call to the planning module to plan something, a memory module to retrieve something, or a tool to execute something. So we'll go back to our example scenario of solving a math problem. So now I know this looks like a whole lot of unnecessary stuff for solving a math problem, but since it was for the sake of example and this is simple, we'll look at it. But in real life, you would probably do this for much more complicated things, and this would be making things a lot easier. So first, the user, maybe I should have added a little user face over here. So the user will give the math problem to the AI agent. So then the AI agent will receive the problem, maybe he will put the problem statement in memory and determine requirements. Next, it will plan a solution. So the planner will create a multi-step plan. Okay, first you need to understand the problem, identify any relevant formulas, perform calculations, and finally generate a PDF report. And then the core will start execution according to that plan. So the core will uh, call the first step of understanding problem. So here the core analyzes the problem, and then if it has a memory module with any uh, knowledge, internet, databases, books, maybe context, any relevant context, it might retrieve that. If not, it will just use its training data to make an inference. So, and then it formulates a step-by-step solution approach. Here, by step, I mean for the mathematical problem, not for the agentic problem. And then the agent core will call the next step, identifying formula. So here, using the knowledge, the analysis that was created in the previous step, it will identify the necessary formulas, and then the memory module will store those. And then maybe if you have a tool, maybe some Wolfram engine or even a textbook, you can refer that and see if this formula is actually valid. So depending on the prompts that we give to the core and the tools at its disposal, it will decide what to do. And then you calculate using that formula. So here we use a tool. So we have a calculate, we assume we have a calculator tool, and the agent core will call that calculator with the formula and the relevant inputs, and it will store these calculation results. Finally, report generation. Again, we assume that there is some sort of, let's say there is a LaTeX generator tool. So maybe the agent core will take the results, the simplifications, the formula, and put everything into the LaTeX generation tool, and then it will generate a PDF using that LaTeX code. And at the end of the day, you get the complete PDF report, and then finally the agent core will send this report back to the user. So now there are no need to do the intermediate prompting or to copy this to a calculator and copy the results again to a report yourself. The AI agent has done everything without any manual intervention. So that is just a very simple example. So in real life, you get much more complicated examples. So here are some sample tools that are commonly used. So you have web search. So maybe you have used the ChatGPT application or the cloud application, and I'm sure there are other things. So if you tell it to search the web, some of them are capable of doing an internet search and getting results. So those are actually agentic AI methods that they're using over there. So then if you have access to databases, maybe you have a customer service agent and it has access to some of the common information in the database, such as how many orders, delays, things like that. It can get data from the database, code interpreters to run code, calculation engines to perform calculations, RAG pipeline. So RAG is actually a very important concept, retrieval augmented generation. That means you can retrieve relevant context from massive amounts of structured and unstructured data and give that to your prompts. So RAG is a whole different subject where you specialize in getting the best relevant data. Then you have API endpoints. You can send an HTTP request or some other request and get some data. And then, especially in real agency systems, for example, you have things like distributed agents or swarm of agents. A tool can be another agent. So when it executes the tool call, what it's actually doing is it's sending a request to another agent, and that other agent will do a whole other thing and send the results back to it. So via tools, even agent to agent collaboration is possible. So next we'll look at some agentic AI systems. So one example, there's this thing called chat dev. So what you do is you give it a simple prompt, develop some sort of game. I have no idea what Gomuku is, but develop a game. So then what it has done is it has an agentic system inside it. That means it has different agents. So maybe there is some sort of centralized coordinating agent, and then you have design agents. So maybe they make UX, UI, architectural designs, or high level designs. So there can be agents specializing in each one. And then you have coding agents. So maybe you have software engineers, front end, back end developers, database engineers, whatever DevOps engineers, whatever the sort of weird engineers you have over there. Engineering agents. So each agent will specialize in something. Maybe writing front end code, one agent will specialize. Maybe another one will specialize in writing back end code. So then you have testing agents. So again, the normal activities that a QA, quality assurance engineer, does, these agents can do. Maybe it can design unit tests, maybe it can just click stuff or call APIs and stress test or whatever it needs to do. And then while these people are designing, these people are coding, these people are testing, there will be a separate documenting agents to document user documentation, developer documentation, whatever else you need. And all of these agents can communicate with each other. So that's what defines an agentic AI system and allows it to do such complicated things. These are all, maybe there's like 10, maybe there's 100 different agents, and each one is coordinated depending on the architecture by a central system, or maybe it's hierarchical. All these agents will work towards a common goal, which is developing a Gomoku game. And that goal, each agent will have a sub goal under that. Okay, plan the different things that you need for this. Design the UI, design API, design physics engine, draw pictures, whatever. Each agent will have its own sub goals which align with the overall goal. So that is how an agentic AI system works. So another common example you might have heard is Devin AI, the world's first fully autonomous AI software engineer. So uh, basically, you can just give him, tell him to create an application about something, and Devin can make that application for you. It's kind of expensive. I don't know if you can use it without like an enterprise this thing, but it was something famous that came up like a year ago, and actually now it's much better than when it was released. And you can do things like integrate with GitHub and let it work on your projects and stuff like that. So maybe there are some other things if you keep up with the tech news, AI news. So recently something called Manus AI was released. Uh, it's a more general one where you can just give it an idea and say, okay, I need help with this task, and it can just do that. And it's a very vast agentic AI implementation. It has access to a wide range of things. It can do a wide range of things because it has so many different uh, AI agent capabilities. So here are some examples of agentic AI applications. So you can see them maybe in customer service. You can do the typical chatbot uh, functionalities, ask, help troubleshoot. Maybe it can do function calling, or if there are specific things, customer service AI agents can sort of retrieve the customer's data, something just an LLM chatbot can't do. Or it can route requests or create tickets, which can then be checked by the support engineers without the support engineers manually having to go and talk to the customer. So customer service agents can do that sort of thing. Then software development agents, I think I gave two good examples. Then you have other fields such as supply chain management, healthcare, content creation, many other places where you have agentic AI applications gaining traction. So yeah, if you want, you can do a quick Google search and see the different areas where agentic AI is being used. Maybe you will come across some big names, frameworks, projects. So if you are interested, you can look for those. So earlier we talked about single agents, which are the building blocks of agentic AI. So when it comes to agentic AI, you generally work with multiple agents. So there are several architectures here. So centralized means there is a single decision-making entity. That means that coordinates all the other agents. Uh, Distributed means there are multiple coordinating agents, which are none of which are sort of a single central entity. Each will just directly coordinate with other agents, and then finally somewhere down the line some agent will uh, return a response or do a final action for the user. And that everything depends on how the agents deal with each other in such a system. So then hierarchical is sort of a cross between. So if you think about it, there is a single decision making entity, and then uh, it coordinates with a few next level entities, and those in turn coordinate. Think about it like teams. So maybe this one is the central one, and maybe there's a lead in designing who coordinates with this one, and that one coordinates with all of these people. And then you have event driven. So again, if you're interested in agentic AI architectures, you can look at these sort of things. And then you have agent communication. So that is an interesting area when it comes to working with multiple agents. So when you're working with multiple agents, so you need to figure out how agent to agent communications happen. So especially if you have a distributed system, how do I give inputs? What sort of protocols do I use? How do I know when to call this, when to call that, whatever. Then agent to human interfaces. So agent to human interfaces are not only important for the human to give an input, but maybe the human needs to know what is going on in the agent, intermediate results, monitor the agent, see if it's going somewhere or all on the way. So a lot of things like that are also important. Then API integration for tool use. So over the past 40-50 years, we have built many software tools. So if you are a large existing company, you probably need to use all of those tools. So then how will the agent communicate with those tools? So then you have standardized messaging formats, which are requirement for mainly these two. So those are some of the things to think about when it comes to working with agentic AI systems. So finally, we'll look at some challenges and limitations. So whether you are working with a singular AI agent or whether you are working with an agentic AI system with multiple agents, you have several sorts of challenges. The first is technical challenges. So one is decision making uncertainty. So the thing is, you're using a large language model to make your decisions for you at the end of the day. So that means maybe there's no 1-0 sort of decisions, no fixed logic, right? So that can vary. So depending on how it goes, there might be problems, and then there might be problems that you simply can't prepare for, like generalization to new situations. For example, if you have a human being and he comes across something he's never seen before, maybe he can figure it out on his own or escalate to a manager. But we don't know how an AI agent may respond to that sort of a thing. Then you have computational resource constraints. So I think that is one of the biggest issues individual developers, especially, and small organizations will have. AI agents require large language models, and then they may require RAG systems and large decision making engines and tools. And all of this requires a lot of computational power, sometimes computational time. So, for example, if we go back here, you will see that there are a lot of different steps, and here the core makes, for each step the core makes a decision, and for some of the steps planner makes a decision. What that means is the core prompts an LLM and gets a response. So that means in this single workflow, there can be a good 20-30 LLM calls. Probably not for something this simple, but there can be that many LLM calls. So then time, costs, those add up. So those are some technical challenges. Then reliability issues. So error propagation. Again, AI agents, especially agentic AI systems, it will have many steps, and the data or the whatever process you are doing will go through multiple agents and multiple tools. So if there is small error at the beginning, that can propagate across. So if there is a hallucination, or if say an agent core mistakenly tries to do a calculation on its own without calling the calculator tool, and there is an error, that error will be propagated throughout all the steps. And further, it can even be amplified during further steps. So that is a major problem. And along with that propagation, you have other problems such as difficulty in determining where that came from. Then you have issues such as adversarial attacks, where some malicious actor is trying to take advantage of the fact that your agent is using an LLM, and it tries to give some input that will break your agent. And then again, handling edge cases and exceptions are things that it might not be reliable at. Finally, you have integration challenges. So like I mentioned earlier, you need to make sure the agent can work with your existing systems. For example, if you have let's say a bank wants to use an AI agent, maybe it has some old Java systems written 20 years ago, and it needs to be able to interact with that. So that sort of compatibility issues are there. Then you have domain adaptation requirements, and also deploying and maintaining AI agents is very complicated. Even for a single agent, when it comes to maintaining, you might have to redo memory retrieval logic, and you might have to redo planning logic and how the different modules coordinate with each other. And that can be a difficult coding challenge, prompt engineering challenge to do. And then when it comes to deployment, especially when you're working with multiple agents, now there's a massive amount of complexity about how each of these agents are going to communicate with each other and that sort of thing. So there's a lot of deployment and maintenance complexity there. But still, given the challenges and limitations, people are continuously developing new ways to work with this. There's a lot of literature on different architectures, different implementations, different tools that can be used. So if you're interested, you can do a search and try to learn more about them. So here I've listed some useful start resources. So Hugging Faces and LLM Agents course, and deeplearning.ai has multiple agentic AI courses. So you can look at those to get some further idea, and maybe I think some of these courses you might get to code a simple agent by yourself. So then you have academic papers, you have open source projects like the one I showed you, chat dev, and then you have some other stuff, agent GPT, baby agi, stuff like that. You can see how agentic systems have been implemented there. Then you have frameworks such as LangChain slash LangGraph. LangGraph is an extension of LangChain. Crew AI, and I saw Amazon has released some different agent building multi-agent tools, and OpenAI has also released some function calling as well as some agent building tools recently. So you can take a look at those and see how they can help you. But if you're interested, my best suggestion would be to forget all of these complicated things and start with a simple course, and start make an Anthropic or OpenAI account, get an API key, use their library, and make a simple agent with a planner, memory, core, and maybe one or two tools, and see how that works. So I think that about covers our introduction. So if you have any questions, we can move on to any questions now. Just check the chat. I can't see it here. If there are any questions on the chat, let me know. So yeah, I think there are no questions. So I think we can wrap up then. If you want, you can direct any questions you have to the organizers. I'm sure they can direct them to me again. And if you want, I can share this. I will share this with the organizers, and they can share this presentation with you also if you want. So thank you, and over to you. Yeah, thank you for letting me do the session, and over to you.
Thank you so much, sir, for that engaging session. Um, if you have any questions, feel free to ask from Mr. Sandil. Type them in the chat, or you can sit on your mic and ask him directly. Looks like there aren't any questions.
We'll assume everyone understood everything. But if you have any questions, again, feel free to direct them to the organizers. I'm sure they can direct them to me, and there are plenty of resources on the internet and the resources I shared, so you can go through those also and try for yourself. And a small announcement, and we will give you a few more minutes to fill out the Google form and secure its certificate. So make sure to submit in time. Over to you, Hansani.
Thank you so much, Mr. Sandil Ranasinghe, for that insightful and inspiring session. Your expertise and experience have certainly added immense value to this event, and we are truly grateful for your time. As a small gesture of our appreciation, we would now like to present you with a token of appreciation. Though it may be modest, it is a reflection of our sincere gratitude for your contribution to TechXplore 1.0 and for sharing your knowledge with us today. Once again, thank you, Mr. Sandil Ranasinghe, for being a part of this session.
So before we conclude, here's something exciting. We have few more amazing sessions lined up for you in upcoming weeks, such as in quantum computing, game development, fintech, and so on. So stay tuned for more updates and don't miss out these insightful sessions. Anthony?
Yes, Ravisha, as we come to the end of today's session, I would like to extend our heartfelt gratitude to Mr. Sandil Ranasinghe for sharing his expertise, to all our participants for your enthusiasm, and to everyone who contributed to organizing this event. A special thanks goes to our sponsors for supporting TechXplore 1.0 and helping us to bring these learning opportunities to all of you. That's all for today. Thank you for joining us and we look forward to see you at our next session. Have a great night.